Hello, everyone. This is an encore of a presentation that we did at the SED-SIG at the OMG technical meeting last week. The topic of the presentation is building a digital thread with SysML v2. My name is Manas Bajaj. I work at Intercax. And with me, I have my colleague, Anya Sharma, who will be doing a demonstration for this presentation. Here are the things that we'll walk through with you on the presentation. We'll talk about the digital thread. We'll introduce the concept of a digital thread. We'll talk about the use cases for a digital thread. And then we'll dive straight into SysML v2 and digital thread. We want to test drive the in-development SysML v2 API and services as part of the OMG SysML v2 submission team and try to build a digital thread out of it to see what happens. We'll do a live demo and we'll discuss some of the next steps and then open it for questions and comments. Any organization that is developing a large complex system is going through what you see on the screen. Any cyber physical system today has a diversity of models that are involved in building their system. There are requirements models, there are architecture models in SysML, UPDM, AADL. There are 3D, 2D mechanical electrical design models. There's the bill of materials that comes from a PLM system. There's software code that realizes a software intensive part of the system. There's simulation that you perform on the system all the way from lump parameter models to three-dimensional FEA and CFD models. There's a lot of project management that goes on. There's test cases that you have to manage, test runs, and so on. It becomes very challenging to define a system when the data for a system is distributed across many repositories and many tools, version managed in each one of them. Because each of these tools or each of these repositories that handle these models have their own version management solution, version managing or configuration management of the system as a whole becomes a big challenge. So how do you do CM of CMs? Impact analysis is another big challenge. When something's changed in some model, some tool, how do you assess the impact of the change to other parts of the system, which are in different models and different tools? And then when you want to do baselining and integration of the system and verification to release a system, either for a review or to a supplier or parts of it for manufacturing, then how do you do continuous integration and milestone releases with proper verification? We live in a world where these models are in different silos, and what you end up is disintegrated silos of models of the same system. A digital thread of a system is a graph, or at least that's what we at Intercax perceive it. And most organizations that are seriously adopting model-based engineering and model-based system engineering solutions have come to the realization that they cannot force all of the models of a system into one single tool, one single platform. We are always going to have the models of a system distributed across many repositories and many tools. So how do you glue them together? The digital thread is one conceptual solution to achieve that. If you look at a digital thread, what it does, it allows you to use the best-in-class tools, use models that are originating from those tools, manage the models the way you've been doing so in the native repositories, but allow for creating inter-model relationships, these highways that are going across the silos. So if you look at it, there are two types of relationships in a digital thread. One, which is the intra-model relationships that are residing within the elements in a single tool, like, for example, satisfy or verify relationships in a system architecture model in SysML, or BOM part relationships in a hardware model managed in a PLM system, and so on. And there's also the intermodal relationships that are crossing the boundaries of these tools, which is what we need to realize the digital thread. And that's often missing. And as you see, these are the kinds of relationships that we are most interested in. Although to truly realize the digital thread, you need both the intra and the intermodal relationship. If you ever want to navigate, as you see on this graph, from a requirement to a system architecture to a hardware part, you not only need to navigate the bridges across these islands, but you also want to navigate the roads within the island. This is one topology of arranging a digital thread. This is not the only way of arranging a digital thread. Different organizations may choose different topologies. They may have different mix of models. In this topology, in this approach that we're using for this scenario, you will see we have requirements and system architecture linked, and then the system architecture then bifurcates into hardware and software. And this doesn't show how the hardware and software is linked, but you could have cross-cutting relationships across these other islands as well. Again, this is just one example topology. There's no predefined methodology or topology of building a digital thread. What's important is that you build one, you have one. What's also important here is that these intermodal relationships that are crossing the islands, are not just basic traceability links. That's good. That establishes basic traceability to be able to link elements in one element in one repository to another. But what's important is that those relationships have a lot of power in it. That means that they can act as conduits of information flow. So in truly, they are like highways across islands. You can drive your vehicles across those islands on the highway. So you need to flow information. When things change, you can propagate that change to other disciplines. And what's also more important is how do you build a digital thread? You can't just piece together different elements manually. So model transformation, the ability to take a model in some discipline and generate a corresponding model in another discipline, and then weave the thread as part of the transmission, is equally important to scale this approach. So there are key use cases that emerge for organizations that are adopting this idea of a digital thread, and most are. One, that you have to be able to connect to different models and repositories in different systems coming from different providers. You have to be able to navigate and search those artifacts in those repositories. You have to be able to create and manage those intermodal relationships, the highways across the islands between the artifacts in different repositories. You have to be able to query, explore, and view the digital thread from multiple perspectives, and be able to do things like change impact analysis, anomaly detection, and pattern matching for validation. And when things change across the ends of a relationship, you should be able to track those changes and report. You should be able to transform models to grow and build the digital thread. The same point I was making in the previous slide. You should be able to transform the models to bulk creation of those intermodal relationships. And then you should be able to compare and synchronize the models across the digital thread, because these models are always evolving almost concurrently in different version management tools. You almost need something at the high level to be able to control what's evolving, what's changing, when, and how. You should be able to generate reports and technical data packages automatically out of the digital thread and not have to manually craft those for a design review or publishing to a supplier. And what's more important at the end is that this should be perfectly accessible via an API. You need an open API to access this information. You do not want this whole digital thread, which is sort of the blueprint, sort of the brain, some of the nervous system behind your system, to be locked in a proprietary solution. Even if it is, it has to be open. It has to be available through an API to allow organizations to build their own apps, to build their own analytics, to build their own use cases on top of the digital thread. Those are some of the key use cases here. During this presentation, we will showcase Syndeia. This is a digital thread platform that we at Intercax build and provide to our customers. Syndeia provides a way to build a federated model, aka a digital thread, by combining models in different enterprise tools and repositories. And more importantly, it provides services for model generation, transformation, compare, sync, visualization, queries, some of which you will see today in the presentation. So our goal with SysML v2, as it's evolving in its development at the SysML v2 submission team, is to test drive a digital thread with SysML v2 via a standard API. So as we know, the SysML v2 came to being by two RFPs right now. One, that is a language RFP. And so the SysML v2 submission team is working on a SysML v2 language meta model. And the second is an API services RFP. The goal here was to provide a standard API that every SysML v2 provider tool could implement, so that users who build apps on SysML v2 could build their app once and work it perfectly fine across multiple providers using the standard API. And that standard API has been in development. We at Intercax have been playing a central role in developing and maturing that part of the specification, along with other organizations that are participating in the SysML v2 submission team. And so we really wanted to test drive that API, that standard API that is being developed by the SysML v2 submission team. So you want to exercise a digital thread or digital thread use cases with SysML v2 artifacts accessed through a standard API. And the goal of doing this exercise was to share experience with the SysML v2 API with the submission team, and to contribute to the improvement of that API, both at the platform independent and the platform specific model level. And we had a goal. We wanted to released this integration with SysML v2 as part of a Syndeia 3.4 release that happened earlier this month. And to do that, we went through the exercise and the rest is history. So let's build a simple little thread with SysML v2. We are firm believers in learning by doing things. So we have a demo that we'll showcase you here. It's a first step towards many such demos to come, but hopefully you like it, and we'll wait for your feedback and your comments to this demo. But before we dive into the demo, let's just introduce the demo to you. So the digital thread we want to build, and again, this is just an example scenario. The digital thread we want to build for SysML v2 looks something like this. We have system architecture models for a vehicle, specifically focusing on the requirements of the part definitions in a SysML v2 model on the left-hand side. Then we have requirement test cases, VNV test cases that are defined in Zephyr Scale and add on top of Jira. These are test cases that are used to verify those requirements. Then while we run the test cases, if there are any issues reported against the test cases or the scenarios, we report those issues in Jira. And then any software code that is used to fix those problems with the test cases of the verification software is reported or resolved on GitHub. And we create a new build of the verification software and post in Artifactory. The verification process, uses the requirements that are part of the system architecture model, uses the software that is used for verification, and then reports any problems to Jira. So you can see some sort of a verification loop here. Also, the part definitions that are there in the system architecture model are defined in an RS Innovator PLM system to refine the part definitions. So you'll see a very simple digital thread like this, but hopefully this will give you an idea of how one can start building a SysML v2 digital thread, using tools like Syndeia. With that, I'll stop briefly. And I'm sorry, this is a one-way track. I can't ask you for any questions or comments at this moment, but we'll be looking forward to your virtual questions and comments on when this is published. But I'll pass it over to my colleague, Anya Sharma, make her the presenter to do the demo, and then I'll come back to the deck. Anya, I'm going to make you the presenter. Give me a second here.
Thank you, Manas.
Can you present?
Yes. Okay. Can you see my screen now?
Yes.
Okay. Hello, everyone. What you see here is the Syndeia web dashboard. Here, if we go to the repositories tab, you will be able to see a list of all the repository types or integrations that are supported by Syndeia. There is RS, there is Artifactory, Bitbucket, Jira, etc. And there is also among these SysML v2 repository type. On expanding this, you will see a list of all the servers belonging to this repository type that are currently connected to Syndeia. We can now browse and explore the data in these servers in the tree pane on the right-hand side right here. To do that, I will simply select the repository and it will appear in the tree pane. I can now expand the repository, and this action will fetch all the projects in that repository using the standard SysML v2 REST API. So all of the data that you will now see is fetched using the standard SysML v2 REST API in real time. Now, when I expand a project here, I will see a list of commits available in that project. So currently we only see one, as this project contains only one commit, but in case there are more, we will be able to see a list of all the commits available. When I expand a commit, I will be able to see a list of all the root level elements in the project as they appear in the commit. Now, when I expand an element, I see two categories: incoming relations and outgoing relations. Now, these are all the relations which are available for this element as target or source respectively. Now, if I expand the outgoing relations category here, I will see a list of all the outgoing relations originating from the root element, and expanding the relation will give me the target elements connected to it. I can keep going further for as deep as the relationships go. So I can just keep expanding these relations. Now, for any particular element, there is another way to view the relationships, and that is through the Relations tab right here. Now, this relation tabs contains two categories of relations, the intermodal and the intramodal. The intramodal category will show you a consolidated list of all the incoming as well as the outgoing relations for a particular element in a tabular format. Here, you will be able to see the direction of the relation, so which is denoted by this arrow here, the name of the relation, and the name of the source and the target connected elements. The intermodal category will show you the related artifacts which are not from the SysML repository, but are connected to this element via Syndeia connections. Both of these relation types are crucial and they play a very important role in the generation of the digital thread, as we will see later on. Another tab here called the Details tab will give you some more information about the selected element, like its name or its ID, its URL. It will also tell you about the name, about the ID of the parent project, the URL of the parent project, and also the type name of this element, for example, requirement usage. There is another tab that you see here, the Search tab. This is not yet implemented, but it will be available in the future releases or service packs. Now, coming back to the element, there is another view through which we can look at the model and its relations called the graph view. Now, once we right click and select the graph view, you will see the same element as a node in the graph that you before saw in the tree. So this element right here, this node that you see, is the same element that we had browsed in that tree. Once we expand this node right here, we will see the immediate intra and intermodal relations for this element as a graph. So now what we previously saw as a tree, we are able to now see that the same thing as a graph. Now, if you notice here, apart from the membership and the import relations coming from the SysML model, there is also a relation coming from outside the SysML repository. So here you see a TM4J or Zephyr scale test case, which was created to verify the Michael-Mas requirement connected to the same Michael-Mas requirement in the SysML model. Now I can right click and go to this test case directly to view further details about it, to see its name or objective and to edit it. So Syndeia has taken me directly to the web page of the test case from this view. Now, if I expand this test case, I will see that it is connected to an RS Innovator part, which in turn, if I expand, I see that it is connected to a vehicle part in the SysML model. We also see that the test case is connected to a Jira issue, which was reported during the test case or test run for this test case. Now, as we did for the test case, we can right click and go to this Jira issue as well to check out more details about it. Now, coming back, we expand the Jira ticket and we see that it is connected to a GitHub branch. Now, this GitHub branch contains the fix for the issue that was raised in Jira. And if I expand this GitHub branch, it will show that it is connected to an Artifactory, to a file which is on the Artifactory server, where the details of the latest build with the fix reside. So here what you did basically, you started from the SysML model, and then you interactively expanded its connections from the test case, which was written to verify it in the TM4J server, you then went on to see the Jira issue, which was created for an issue that occurred in the test case. Then you went to the GitHub branch where the fix for the issue was uploaded. And from there, finally, to the file in the Artifactory server containing the build details for this fix. Now, the relations which are coming from the SysML repository, all of these are intra-model relations, which are fetched from the SysML server in real time by using the standard SysML v2 REST API. And these relations that you see pointing to the artifacts of different repositories are the inter-model relations, and they are persisted in Syndeia. Now, since these relations are persisted, you can also view them as a graph using the standard Gremlin query language. Now, to do that, we can go to the Gremlin dashboard right here. And I will create a simple Gremlin query using the ID of the element. Now, this ID I can get easily from right here. So this is the ID that I have used in my query. Now, the query that I have built simply fetches a vertex which contains this ID value as one of its properties. It then recursively navigates through the connected edges to fetch the path. Now, when I run this query, you will see the complete digital thread comprising of all the intermodal relations starting from the SysML element right here. Now, this kind of view is possible because Syndeia treats the digital thread as a graph with the artifacts in different repositories as the nodes or the vertices, and the relation between them as the edges. Now, as we did in the Digital Thread Explorer, I can go to the web page of any of these nodes by simply right-clicking and going for more details. And I can simply go to the web page directly from here. I can also see some basic details about a node by using this properties option. The details shown here are similar to what we saw in the details tab in the repository view. Now, since all of these actions are done using the Syndeia REST API calls, you can also see the raw JSON of the response that was received right here. So this is the raw JSON that was received from the Syndeia server when this query was fired to it. Okay, now the relations that you see here, they can be easily created using the Syndeia dashboard relations pane. Now, to do that, you can go to the relations tab and just select a container. So this is where all the relations will reside in Syndeia. You then need to select the source repository. Here, I will select the SysML v2 repository because I want to connect it. I want to connect the vehicle requirement to a file in Artifactory, which contains the updated change log for the fix that was applied. So once you select a repository, you need to then browse to the element that you want to create the connection to. So we'll just browse to it. Relations, membership, package. Okay. Okay. And here it is. So this is the requirement usage element that I want to connect to Artifactory, and I will do the same here. I'll select the Artifactory repository and then browse to the file that I want to create the connection to. So it's right here. And then I'll simply create the connection. So we see that the connection was created successfully. Now, once this is done, you will be able to see this connection in all of the views that we have studied till now. So you will be able to see these connections in the relation view right here. So this is the new relation that just got created. You will also be able to see this in the graph view if you just expand it. So this is the new node that you are now able to see, the connection to the Artifactory document. And you will also see the same thing using the same Gremlin query by just refreshing it. And here it is. So basically, what we saw here in summary is different types of views that we can use, that we can see the model in. So we saw a tree view, a graph view for your digital explorer, and then we also saw a tabular format for those relations, for the inter and intra-model relations. And then we also saw how we can use a simple standard Gremlin query to fetch and view the digital thread explorer in real time. So that's it from me. Thank you. And over to you, Manas.
All right. Thank you, Anya. I'll go back to the mass requirement that you were showing. Just want to emphasize the RS relationship to the RS innovator part there. If I right click on the vehicle mass requirement and go to the graph view, I can see that in the graph as Anya was showing. If I expand it, I can see the other SysML v2 elements to intramol relationships. And then I can see this vehicle part in the SysML v2 model. If I expand this one, I can see this link to a vehicle element. In this case, it's a part that's coming from the RS Innovator platform. If I expand this one, I can start to dive into the bill of materials for that vehicle. And if I pick one of them up, like the powertrain for the vehicle, and expand that further, this is going to get me the other elements of the BOM downstream from the powertrain. And again, these interactions are happening in real time as you're seeing it. These are live queries going to the RS Innovator server and fetching data and rendering it through Syndeia Cloud's API. And if I right click on any of these, like the vehicle, and I go to more details, just like Anya was showing, you can actually see it in the RS platform, the BOM structure for that element that you selected. And you can dive in and look at more details here if you choose to. All right, one of the key things that we have in the Syndeia platform is the ability to graph queries. So for example, if you go to the Swagger doc here from the platform, you can actually go and look at the entire Syndeia Cloud API, and the same graph queries that you're seeing that are happening from a SysML v2 model to fetch all of its intra or intermodel relationships can be done through this API Swagger doc over here. We won't dive into the details right now, but you can make the same graph query right here that, as Anya was showing you, that is being made behind the scenes when we fetch those intra and intramodel relations. All right, we'll get back to the deck to wrap this up. So what we've shown you is a set of, if you go back and assess, our goal was to test drive a digital thread example with SysML v2 models. What we've shown you is that we are able to connect to different repositories, and we're able to navigate and look inside a SysML v2 model, as Anya was showing you, browsing through the tree, browsing through the graph view. So that seems pretty fine. The standard SysML v2 API is working fine. We as a provider or a consumer of SysML v2 API didn't see any problems with interacting with the standard API and embedding it in our own solution. Also, the use cases that we realize in the Syndeia platform for digital thread, we were able to carry out those also pretty well with the SysML v2 API, standard API. For example, creating and managing the intermodal relationships from and to SysML v2 artifacts and other repositories. And we also saw that we were able to explore and query the digital thread in various forms, either interactively, like exploring a friends of friends network in the digital thread explorer, or through a direct Gremlin graph query to figure out the intermodal relations and to see it in the tree view as well. Now, we showed that in the SysML v2 model tree, we have support for commits right now. We don't have support for branching yet. Branching was introduced in the latest release of the SysML v2 API that was just released a few weeks back. And so we are working on implementing that also. And so hopefully in the next time we record this video, you should be able to see branches in a SysML v2 model and be able to navigate across branches. This presentation doesn't get into transformation. So as you know, that model transformation is a very key part of Syndeia platform. it's not just linking things, but it's also transforming models and bulk creation of intermodal relationships as a part of the model transformation. So we have not gotten that working yet. We're trying to work on the capability to demonstrate transformation of SysML v2 models to models in other repositories and vice versa. And then the ability to compare and synchronize SysML v2 models to maintain the digital thread in its latest state. And that would be very interesting because synchronization or updating the SysML v2 model would require you to create commits into the SysML v2 project. And with branching, then you have to also be cognizant about which branch you're creating the commit on. So that'd be very interesting. We really look forward to trying that out and share our experience and share our results with the SysML v2 submission team. Also, we are exploring with the idea of generating reports and technical data packages, but the types of views that you saw on the Syndeia web platform can all be exported out from there. And you can write your own apps to the digital thread API, which is a key part here. So you can use the SysML v2 standard API to explore the SysML v2 model. And then you can also use the digital thread API that Syndeia provides to navigate across the SysML v2 model into other relationships. Now, the SysML v2 standard API does provide a provision for an external relationship, which is what we're trying to implement now. And that's a more standard solution to managing the intermodal relations SysML v2. Next time we'll come around to you with some good test cases to demonstrate that. So hopefully this was a good viewing for you. You probably learned something, and we look forward to your comments and your questions. And if you want to reach out to us, you have our email addresses there. Don't spam us. Don't submit our email to spam bots, but feel free to ask your questions, send us an email, give your thoughts, comments. This video will be posted on YouTube, and you'll be able to see it through the Intercax Syndeia channel. Thank you, everyone. And with that, we'll stop the presentation.